Number system. Brief detail into decimal number system. The decimal number system is the most commonly used and standard system in daily life. It uses number 10 as base radix, therefore it has 10 symbols. The number from 0 to 9, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. As one of the oldest known numeral number system, decimal number system was used by many ancient civilizations. The difficulty of representing very large number in the decimal system was overcome by the Hindu-Arabic numerical system. The Hindu-Arabic numerical system gives position in the digits of numbers and method works using powers of the base 10 digit raised to 10th power following their position. For instance, take number 2345.67 in the decimal system. The digit 5 is the position of ones, which is equal to 1. 4 in the position of tens. 3 is the position of hundreds. 2 is the position of thousands. Meanwhile, the digit 6 after decimal points in the tens and 1 to 10, which is 10 is to 1, and 7 is the and hundreds 1 to 100, which is 10 is to 2 position. As a computer programmer or an IT professional, you should understand the following number system which are frequently used in computers. Number system. Binary number system. Base 2 digit is 0 to 1. Octal number system. Base 8 digits use 0 to 7. Hexadecimal number. Base 16 digits use 0 to 9 letters use ENF. Number system. Brief detail into decimal number system. The decimal number system is the most commonly used and standard system in daily life. It uses number 10 as base radix, therefore it has 10 symbols. The number from 0 to 9, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. As one of the oldest known numeral number system, decimal number system was used by many ancient civilizations. The difficulty of representing very large number in the decimal system was overcome by the Hindu-Arabic numerical system. The Hindu-Arabic numerical system gives position in the digits of numbers and method works using powers of the base 10 digit raised to 10th power following their position. For instance, take number 2345.67 in the decimal system. The digit 5 is the position of ones, which is equal to 1. 4 in the position of tens. 3 is the position of hundreds. 2 is the position of thousands. Meanwhile, the digit 6 after decimal points in the tens and 1 to 10, which is 10 is to 1, and 7 is the and hundreds 1 to 100, which is 10 is to 2 position. As a computer programmer or an IT professional, you should understand the following number system which are frequently used in computers. Number system. Binary number system. Base 2 digit is 0 to 1. Octal number system. Base 8 digits use 0 to 7. Hexadecimal number. Base 16 digits use 0 to 9 letters use ENF. Why do we need to learn binary system? From Richard Fox. Why is all this important? It would not be on our computers based on 10 decimal, but computers store information, transmit in all information, and pass all information in binary instead of decimal. And although it as an IT specialist, you may never hope to worry about looking at or expressing data in binary. The use of non-decimal numbering system thus comes from time to time. The common occurrences of the non-decimal numbering system is that the network communication IP address are sometimes denoted to binary, and IPv6 address are denoted as hexadecimal. Octal is also used for various computers application, but that is happening far less often. How to read a binary number? To convert binary to decimal, basic knowledge on how to read binary number might help. As I mentioned in the positional system of binary, each bit binary digit is a power of 2. That means that every binary number could be represented as power of 2 with the rightmost of the being in the position of 2. Counting binary numbers. When counting binary numbers, think of it having only two fingers, one for the number 1 and the other for counting 10. So for example, instead of 2 binary we get 10, instead of 3 we get 11, instead of 4 we get 100. Converting binary numbers to decimal numbers. There are two methods to apply binary to decimal conversion. The first one uses the positional representation of the binary, which is described above. The second method is called double and it used for converting longer binary strings faster. It doesn't use the position. Converting binary number to decimal numbers. To get the binary equivalent of a decimal number, we have to divide the decimal number by 2. Save the remainder and the divide quotient 2 again, and then save the remainder. You have repeat it until the quotient is 0. You then have to get all the saved remainders and write them down with the last remainder you got as the leftmost digit of the binary, and get the first remainder you save as the rightmost digit. For more detailed process, write down the decimal. Divide the number by 2. Write the quotient result below. Write the remainder to the right of the number. Continue dividing the quotient until the quotient is 0. You write the remainder horizontally using the bottom remainder as the highest digit, going the binary equivalent or decimal number.
In this video, we're going to talk about how to convert binary numbers into decimal numbers. And we're going to go through plenty of examples so you can master this topic. Let's start with this example, 1010. How can we convert this particular binary number, which is a base 2 system, the digits can only be 0 or 1, how can we convert it into a decimal number? Now the first value is 2 to the 0 power. And the second one is going to be this number times 2 to the first power. And the third value, going from right to left, is 0 times 2 squared. And this one is going to be 1 times 2 to the third power. So 1 times 2 to the third power, that is equal to 2 to the third power. And then if we multiply 2 squared by 0, that's going to give us 0. And we're going to add these values. And then it's going to be 1 times 2 to the first power, which is just 2 to the first power. And then 0 times 2 to the 0 is 0. So everywhere you see a 0, you could ignore it. So we only need to focus on the numbers that contain a 1. Now, let's add up these numbers. So what is 2 to the third power? 2 to the third power is 2 times 2 times 2, which is 8. 2 to the first power is simply 2. So we're going to get 8 plus 2, and so the answer is 10. So the binary number 1010 has a value of 10. Now let's try another example. 10010. So if you want to try it, feel free to pause the video. Go ahead and write this number down and convert the binary number into a decimal number. So let's start from the right side. This is going to be 2 to the 0 power. The next number is 2 to the first power. It's 0 times 2 to the 0, by the way. And then the next number is going to be 0 times 2 squared, and then 0 times 2 to the third, and then 1 times 2 to the fourth. Now, we don't need to worry about the zeros, so let's ignore those numbers. Focus on the numbers that have a 1, because those numbers will contribute to the final answer. So this is going to be 1 times 2 to the fourth power, which is simply 2 to the fourth power. And then this is 1 times 2 to the first power, which is just 2 to the first power. So what is 2 to the fourth power? So 2 times 2 times 2 times 2. 2 times 2 is 4, and 4 times 4 is 16. So 2 to the fourth power is 16. Plus 2, and so this will give us 18. And so it's not very difficult to convert a binary number into a decimal number. As long as you follow the process, you're going to get this right. Now, here's some information that you may want to know. 2 to the 0 power is 1. In fact, anything raised to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And then 2 to the fifth power, that's 32. 2 to the sixth is 64. 2 to the seventh is, that's 128. And then 2 to the 8 is 128 times 2, or 256. And so, if you know these values, you can quickly perform the operations that's necessary when converting a binary number into a decimal number. So let's try another example. 1, 1, 0, 1, 1. So go ahead and convert this number into a decimal number. So this is going to be 2 to the 0 times 1, and then 2 to the first power times 1, 2 squared times 0, 2 to the third times 1, and then 2 to the fourth times 1. And just like before, we are going to ignore the 0 values and focus on the numbers that have a binary value of 1. So this is going to be 2 to the fourth, and then plus 2 to the third power, and then plus 2 to the first, and then plus 2 to the 0 power. So based on that table, or rather the information on the last page, we said that 2 to the fourth power is 16, 2 to the third is 8, 2 to the first is 2, and 2 to the 0 is 1. So now let's add. 16 plus 8 is 24, and then 2 plus 1 is 3. So the final answer is 27. And so that's how we can convert a binary number into a decimal number. Now, for the sake of practice, go ahead and try these two example problems. So convert these two numbers into decimal numbers. Feel free to pause the video and work on these problems. So let's start with the first example on the left. So I like to space out the numbers. It makes it easier. So this number is going to be associated with 2 to the 0, and then 2 to the first. And then we're going to follow the same process for all of the other examples. And now let's focus on the numbers that contain a 1. So what we have is 2 to the 6 plus 2 to the fifth power plus 2 to the first power, and then plus 2 to the 0 power. So 2 to the 6th power, we said that's 64. 2 to the 5th is 32, and then plus 2 plus 1. Now 64 plus 32, that's 96. 2 plus 1 is 3. And so the final answer for the first example is 99. And so that's it for this one. Now let's move on to the next one. So let's rewrite the number. So we have 0, 1, 0, 1, 0, 1, 1, 0. Now let's write these numbers at the top. And once again, let's focus on the numbers that contain a 1. Now let's add up these numbers. So this is going to be 2 to the 6 plus 2 to the fourth power plus 2 squared, and then plus 2 to the first power. So 2 to the 6 is 64, 2 to the fourth is 16, 2 squared is 4, and 2 to the first is 2. So 64 plus 16, that's going to be 80, and then 4 plus 2 is 6. So the final answer for this example is 86. Now, what if you're given a fractional binary number, how can you convert that into a decimal number? For instance, let's say if you have the number 1, 1, 0, 0 with a decimal point and then 1, 0, 1. How can we convert that into a decimal number? So the first number that's to the left of the decimal point, that's 2 to the 0 as always, and then 2 to the first, 2 squared, and the last one is associated with 2 to the third. But what about the numbers to the right of the decimal? Well, if we follow the pattern of exponents that we see here, the number that's less than 0 is negative 1. So this has to be associated with 2 to the minus 1, and then to the minus 2, and then 2 to the minus 3. Just like before, we're going to focus on the values that bear a 1. And so we're going to add 2 to the third plus 2 squared plus 2 to the minus 1 plus 2 to the minus 3. Now, 2 to the third is 8, and 2 squared is 4. But now, what is 2 to the minus 1? We know 2 to the first power is 2, so 2 to the negative first power is 1 over 2. Now, 2 to the third is 8, so 2 to the negative third is going to be 1 over 8. And so 8 plus 4 is 12, and then we have 1/2 plus 1 over 8. 1 over 2, if you type that in your calculator, that's 0.5. And 1 over 8, 1 divided by 8 is 0.125. So adding up these three numbers will give us this answer, 12.625. And so that's how we can convert a fractional binary number into a decimal number. Now earlier we said that 2 to the fourth is 16. So 2 to the negative 4 is going to be 1 over 16. 2 to the fifth is 32. 2 to the negative 5 is 1 over 32. So notice the pattern that you see here. 2 to the 6 is 64. 2 to the negative 6 is 1 over 64. And so forth. So when dealing with fractional binary numbers, whenever you have negative exponents, just consider the ones with a positive exponent. So if 2 to the 7 is 128, then you know 2 to the negative 7 is just 1 over 128. So here's another example that you could try. 10011.011. Go ahead and convert that into a decimal number. So let's begin by putting the appropriate values next to each number. So on the left is going to be 2 to the minus 1, 2 to the minus 2, and 2 to the minus 3. So let's focus on only the ones that we see. So it's going to be 2 to the fourth power plus 2 to the first power plus 2 to the 0 power, and then plus 2 to the minus 2 plus 2 to the minus 3. 2 to the 14, not 14, but 2 to the fourth power is 16, and 2 to the first power is 2, 2 to the 0 power is 1, and then 2 to the negative 2. If 2 squared is 4, 2 to the negative 2 is 1 over 4. And if 2 to the third power is 8, 2 to the negative third power is 1 over 8. So we have 16 plus 2 plus 1, so that's 19. And then 1/4 is 0.25. And 1 over 8, we said that was 0.125. So adding these three numbers is going to give us the final value of 19.375.
Octal numbering system. Octal numbering system use 8 digits 0, 1, 2, 3, 4, 5, 6, 7. Also called as the base 8 number system. Its position in each octal number represents 0 power of the base 8, example 80. Last position in an octal number represent the x power of the base 8, example 8x, where the 8 represent the last position 1. The octal number system, or shortly OCT, use a number 8 as the base radix. As the base 8 numerical system, it uses 8 symbol, the number from 0 to 7, namely 0, 1, 2, 3, 4, 5, 6, and 7. Although it was used by some Native American tribes until 20th century. The octal system has become a popular early ages computing as a language of a computer program. This is because an octal system shortens binary by simplifying long and complex chains binary display used by computers. The octal system is mainly used for counting binary in groups of 3 each. Octal digit represent 3 binary digits since 8 and 2. 8 is 2 to the third power of 23. The octal system became a perfect abbreviation of binary machines that employ word size divisible by 3, in which 6-bit, 12-bit, 24-bit, and 36-bit. Nowadays, most of modern systems use hexadecimal rather than octal. However, octal numbers are an important part of knowledge in electronics. Converting octal number to decimal number. An octal number can be converted to a decimal number by following simple rules. Here are 2 ways to convert octal to decimal step by step. The first is a more conventional method, whereas the second one applies the repeated division and remainder algorithm technique in reverse. Method 1. Step 1. Find out the number of digits in the number. Step 2. Let the number have the digits. Step 3. Think of the digits position from the right to left has the position. This means you're showing the position of each digit has increasing power of 8. Step 4. Multiply each digit with 8 in being position. Step 5. Add all the individual result from the multiplication process. Step 6. The result will be decimal equivalent of the given octal number. Method 2. Step 1. Start with the result. Step 2. Remove the most significant digit in the octal number, the leftmost one. Add the result. Step 3. Multiply result by 8. Step 4. Go to step 2 and remove the leftmost side digit and it result you. Go to step 3. And the last step is step 5. Keep it up until an octal digit have been removed. When you left with only one digit, add it to the previous result. Do not multiply by 8. The sum from the last additional is decimal equivalent.
In this video, we're going to talk about how to convert an octal number into a decimal number. So how can we do that? Well, let's start with a simple example. Let's say we have 370 in the octal system. So what we're going to do is we're going to multiply the 0 by 8 to the 0 power, and then we're going to multiply the 7 by 8 to the first power, and the 3 by 8 to the second power. And we're going to add up all these numbers. So this is going to be 3 times 8 squared plus 7 times 8 to the first power plus 0 times 8 to the 0 power. 8 squared, that's 8 times 8, which is 64. And 7 times 8 is 56. And 0 times anything is 0. Now 3 times 64, that's 192. And then we have 192 plus 56. And so 2 plus 6 is 8, 9 plus 5 is 14, carry the 1. And so we get a total of 248 in the decimal system. So that's how we can convert an octal number into a decimal number. Now let's try another example. 1071 in the octal system. Let's convert that to a decimal number. So the first one, the 1, we're going to multiply that by 8 to the 0. And then the 7, we're going to multiply that by 8 to the first power. And the 0 by 8 squared. And the 1 by 8 to the third. So this is going to be 1 times 8 to the third plus 0 times 8 squared plus 7 times 8 to the first power plus 1 times 8 to the 0 power. So what is 8 cubed? So 8 times 8 times 8. That's going to be 512. 0 times 8 squared is 0. 7 times 8 is 56. And 8 to the 0 power is 1. So 1 times 1 is 1. So we have 512 plus 56 plus 1. And that's going to be 569 in the base 10 system. And so that's it for that one. Now what about this one? 16,475 in the octal system. Let's convert it to a decimal number in the base 10 system. So the first number, the 5, we're going to multiply by 8 to the 0, and the second number by 8 to the 1, and the third by 8 squared, and the fourth by 8 cubed, and the last one by 8 to the fourth. So this is going to be 1 times 8 to the fourth, plus 6 times 8 cubed, plus 4 times 8 squared, and then plus 7 times 8 to the first power, and then plus 5 times 8 to the 0 power. Now 8 raised to the fourth power. If we multiply 4 8s together, 8 times 8 times 8 times 8, that's 4,096. Now 8 to the third, we know it's 512. And then 8 squared is 64. 7 times 8 is 56. And I need to put a plus sign here. And then 8 to the 0 is 1. So we have 4,096. And then 6 times 512, that's 3,072. And 4 times 64 is 256. And then plus 56 plus 5. So let's go ahead and add up these 5 numbers. And so the sum comes out to 7,485 in the base 10 system. So this is the final answer. Now, what if we have a fractional number, let's say 425.28 in the octal system? How can we convert that to a base 10 number in the decimal system? So we know that the 5 we need to multiply by 8 to the 0, and the 2 by 8 to the 1, and 4 by 8 squared. So if we follow the pattern of exponents that we see here, the next number has to be 8 to the negative 1. So the number to the right of the decimal we need to multiply by 8 to the minus 1, and then the last number by 8 to the negative 2. So we're going to have 4 times 8 squared plus 2 times 8 to the first power plus 5 times 8 to the 0 power plus 2 times 8 to the minus 1, and then plus 8 times 8 to the minus 2. Now we know that 8 squared is 64, and 2 times 8 is 16. And 8 to the 0 is 1, 5 times 1 is 5. Now what about 2 times 8 to the minus 1? 8 to the negative 1 is the same as 1 over 8. And so therefore, this expression becomes 2 times 1 over 8. Or we could say it's basically 2 divided by 8. Now for this expression, 8 to the negative 2 is 1 over 8 squared. And so what we have is 8 divided by 8 squared, which I'll write that here. So 4 times 64, that's 256. Now we can add 16 plus 5, that's going to be 21. And then 2 over 8, or 2 divided by 8, that's 0.25. And then 8 divided by 8 squared, or 8 divided by 64, that's 0.125. Now let's add up the numbers. So we have 256 plus 21 plus 0.25 plus 0.125. And so our answer is going to be 277.375 in the base 10 system. And so now you know how to convert a fractional octal number into a decimal number. Thanks for watching.
Converting decimal number to octal number. Decimal to octal conversion can be achieved by applying a repeated division, remainder, or logarithm. Simply put, the decimal number is repeatedly divided by the radix 8. In between this division, the remainders give the octal equivalent in reverse order. Here is how to convert decimal to octal step by step. Step 1. If the given decimal number is less than 8, the octal equivalent is the sum. If the given number is greater than 7, divided by 8. Step 2. Write down the remainder. Step 3. Divide the part before decimal point of quotient by 8 again. Step 4. Write down the remainder. Step 5. Continue this process by dividing by 8 and nothing remainders until the last decimal digit and left less than 8. When the last decimal digit is less than 8, quotient will be less than 0 and the remainder will be digit itself. Step 6. Step 7. The last remainder you get will be the most significant digit of your octal value, while the first remainder of step 3 is the last digit significant to the therefore you write remainder in reverse order, starting the bottom with the most significant digit and going to top. You will reach the octal value given decimal number. Converting octal to binary numbers. Converting from octal to binary is a very straightforward method because octal numbers are shortened version of binary string. Remember that each digit represents its 3 binary digits. Therefore, the octal digit should give 3 binary digits. While octal can be converted to binary indirectly, first to the decimal, then to binary. A direct method to convert octal to binary with a step as follows. Step 1. Write down the octal number separating the digit. Each octal digit represents the binary digit. Therefore, it's equal to the power of 2. The rightmost equals 2. The next equals 2. 2 is to the power of 1 and the left made 1 equals 2. 2:2. Write this number 4 and 2 and 1 below the octal digit. Step 2. Determine which power of 2, 4, 2, or 1 sum up the octal digits. For example, if your octal number is 6, this means 4 and 2 sums up to 6 and it's not used. If your octal number is 2, only 2 is used, 4 and 1 are not. Step 3. Write down 1 below those 4 and 2 and 1 that are used. Write down 0 below those are not used. Step 4. Read 1 and 0 you just wrote from the left right. You'll get your binary number.
In this video, we're going to talk about how to convert an octal number into a binary number. So let's say if we have 56 in the base 8 system, that is in the octal system, how can we convert that to a number in the binary system, that is in the base 2 system? So what you want to do first is separate the 5 and the 6. Now you want to break it down to these numbers, 4, 2, and 1 for each one. 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4. Now, to convert 5 into a binary number, you need to realize that 5 is the sum of 4 and 1. So because we used 4 and 1, we're going to replace that with a 1. We didn't use 2, so we're going to replace that with a 0. Now, 6 is the sum of 4 and 2. Since we used the 4 and 2, we're going to replace that with a 1. We didn't use the 1, so let's replace that with a 0. So 56 in the octal system is equal to 1, 0, 1, 1, 1, 0 in the binary system. And so this is the final answer for this problem. And that's how you can convert a number in the octal system to a number in the binary system. Now let's try another problem. So let's convert 35 from the octal system to a number in the binary system. If you want to pause the video, feel free to do so and try this problem. So let's begin by separating the 3 and the 5. And let's write the numbers 4, 2, 1 for each. Now 3 is the sum of 2 and 1. So we're going to replace 2 and 1 with a 1, and we didn't use the 4, so let's replace that with a 0. Now 5 is the sum of 4 and 1. So let's replace 4 and 1 with a 1. We didn't use a 2, so let's substitute that with a 0. And that's it. So 35 in the octal system, we can write it as, now here's the question, should we write it as 0, 1, 1, 1, 0, 1? Now, if you have a 0 in the front, you need to get rid of that 0. So therefore, we only need to use these 5 numbers. So the answer is going to be 1, 1, 1, 0, 1. So watch out for that. So this is the answer. Now, if you want to check your work, here's what you can do. Let's convert the octal number into a decimal number, a number in a base 10 system. To do that, you need to multiply the 5 by 8 to the 0 and the 3 by 8 to the 1. So it becomes 3 times 8 to the first power plus 5 times 8 to the 0 power. 3 times 8 is 24. 8 to the 0 power is 1. So that's 5 times 1, which is 5. And so the sum is 29. Now, to convert the binary number into a decimal value, here's what you need to do. So the first number we need to multiply by 2 to the 0, the second by 2 to the first, and then 2 squared, 2 to the third, and 2 to the fourth. So we have 2 to the fourth plus 2 to the third plus 2 squared, and then 0 times 2 to the first power is 0, and then we have 1 times 2 to the 0. 2 to the fourth is 16, 2 to the third is 8, 2 squared is 4, anything raised to the 0 power is 1. Now, 16 plus 8, that's 24. 24 plus 4 is 28. 28 plus 1 is 29. So we get the same answer. Because these two are the same, we know for a certainty that these two must be equivalent to each other. And so that's how you can check your work. For the sake of practice, let's do one more example. 643 in the octal system. Let's convert it to a number in a binary system. So the first thing we should do is separate each digit. Now to get 6, we need to add up 4 and 2. And so let's replace those numbers with a 1, and then the other one that we didn't use, replace it with a 0. To get 4, all we need to use is 4. So this is going to be 1, and then we didn't use the other numbers, so 0 for the 2 and 0 for the 1. Now to get 3, we need to add up 2 and 1. So that's going to be 0, 1, 1. And thus, we could see our answer right here. So 643 in the octal system is 1, 1, 0, 1, 0, 0, 0, 1, 1. And so this is the final answer. So now you know how to convert a number from the octal system to the binary system.
Converting binary numbers to octal numbers. Converting from binary to octal is very easy since octal numbers are only a specified version of binary strings. You just need to remember each octal digit represents 3 binary digits so that the binary digits will give only one octal digit. While the method is quite easier than it sounds, it's always useful to use a binary to the octal conversion chart to save time. Step 1. Write down the binary number and group the 0 and 1 in the set of 3. Start doing this from the right. If the leftmost group doesn't have enough digits to make at least set 3 extra 0 to make another group. Step 2. Write 4 and 2 and 1 each group. This ways that this position is 2 is to 2, 2 is to 1, and 2 is to 0. Step 3. Write down the group 3 binary will give 1 digit octal multiplied by 4, 2, and 1 by the digit above. Step 4. Add the production within each set of 3. Write sums below the group they belong to. The digit you get from the sums each group will give you the octal number from left to right.
In this video, we're going to talk about how to convert a binary number into an octal number. So let's say if we have the number 110101. How can we convert that to an octal number? So what do you think we need to do? So what we need to do is separate this into two numbers in groups of 3. So the first group of 3, we have 101, and the second one is 110. Now the first number has the value of 1, the second number we need to multiply by 2, and the third by 4. So 1 times 4 is 4, 1 times 2 is 2, 0 times 1 is 0. So all we're going to do is just add the 4 and the 2, and so that's going to give us 6. Here we only need to add the 4 and the 1 because 1 times 4 is 4, 1 times 1 is 1. And so this will add up to 5. So our answer is going to be 65. So that's how we can convert a binary number to an octal number. Now let's try another example. So let's say if we have the binary number 1001111. Go ahead and convert it into an octal number. So first, let's separate it into groups of 3. So for the first group of 3, we have 100. So everywhere there's a 1, we're going to use the number that's associated with it. So the binary number 100 has the equivalent of being 4. Now let's do the same thing for this one. So the number is 111. So because we have a 1 for each, we're going to use the 4, the 2, and the 1. 4 plus 2 plus 1 is 7. So we're going to read it this way. Our answer is 47 or 47. So it's 47 in the octal system, which is a base 8 system. Now let's try a different example. So instead of having 6 binary numbers, what if we have 7 binary numbers? How can we convert this into an octal number? So go ahead and try it. So once again, we're going to separate it into groups of 3. So here's the first group of 3, and here is the second. Now, because we don't have enough numbers to make another group of 3, we're going to add 2 zeros. So it's going to be 0, 0, 1, and then in blue we have 1, 1, 1, and then in red 1, 1, 0. So let's start with this example. So we have 4, 2, 1, and so this will have a value of 1. For the next one, it's 1, 1, 1. So we need to add up each number. We have a 1 associated with the 4, the 2, and a 1. 4 plus 2 plus 1 is 7. And for the next one, we have a 1 in front of the 4 and in front of the 2. So we're only going to add 4 plus 2, which is 6. And so you can see the answer. It's 176. And so that's it for this problem. Now, for the sake of practice, let's do one more example. So let's say we have the binary number 11011010. Go ahead and convert it into an octal number. Feel free to pause the video. So the first group of 3 is 0, 1, 0. And the second group of 3 is 0, 1, 1. And then the last one is 1, 1, but we're going to add a 0 to it. So it's 0, 1, 1, and then 0, 1, 1, and 0, 1, 0. So let me just color code it so you can see which one matches. And so let's write the numbers 4, 2, 1. So everywhere there's a 1, add up that number. So we're going to add up 2 and 1. So 2 plus 1 is 3. And here we're going to do the same thing. Here we only have a 2. So our answer is 332, or 332 in the octal system. And so that's a very simple way in which you can convert a binary number into an octal number.
Hexadecimal number system. Hexadecimal number system used 10 digits and 6 letters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F. Letter represent the number starting from 10. A is to 10, B is to 11, C is to 12, D is to 13, E is to 14, F is to 15. Also called a base 16 number system. Each position of hexadecimal number represents a 0 power of those base 16, example of 160. The hexadecimal shortly hex used the number 16 as the base radix. Base 16 number system use symbol. These are 10 decimal digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the first 6 letters of English alphabet A, B, C, D, E, F. The letter used because of need to represent values 10, 11, 12, 13, and 10, 11, 12, 13, 14, and 15, each one single symbol. Hex should mathematical information technologies and more friendly way to present binary number. Each hex digit represents 4 binary digits. Therefore, hex is a language to make binary and abbreviated from 4 binary digits, also called nibbles, up to half a byte. This means byte can carry binary values from 0, 0, 0, 0, and 1, 1, 1, 1. In the hex, this can represent the friendlier fashion ranging from 0 to F. In HTML, colors can be represented by a 6-digit hexadecimal number. F represent where the 00 represent black. Converting hexadecimal to decimal numbers. Hex is a basic 16 number and decimal is a base of 10 number. We need to know the decimal equivalent of every hex number digit. See below of the page, check the hex decimal chart. Here are the steps to convert hexadecimal. Step 1. Get the decimal equivalent of the hex from the table. Step 2. Multiply every digit with the 16 power of digit location. Example 0 base 7 DE. E location is 0, D location is 1, and the 7 location is 2. Step 3. Sum up all the multipliers.
In this video, we're going to focus on converting a hexadecimal number into a decimal number. The decimal number system is a base 10 system, and the hexadecimal number is a base 16 number. Hexa represents 6, decimal is 10, so 6 plus 10 is 16. But how can we convert a hexadecimal number into a decimal number? Before we can do that, we need to know the relationship between decimal numbers and hexadecimal numbers. A decimal value of 0 corresponds to 0 in the hexadecimal system. 1 corresponds to 1, 2 corresponds to 2, and so forth, all the way to 9. So 7 corresponds to 7, 8 corresponds to 8. Now once you get to 10 in the decimal system, that's A in the hexadecimal system. 11 corresponds to B in the hexadecimal system. 12 corresponds to C, 13 corresponds to D, 14 corresponds to E, and 15 corresponds to F. So F is the highest digit in the hexadecimal system. Notice that the highest number that we see here is 15. Now, the hexadecimal system is a base 16 system, and if you include 0, we have a total of 16 numbers. So just keep that in mind. Now let's work on some examples. So consider the number 23E in the hexadecimal system, so we have a subscript of 16. Convert the hexadecimal number into a decimal number. So how can we do that? The first letter E, we're going to multiply it by 16 to the 0 power. The second number, 3, going from right to left, we're going to multiply that by 16 to the first power. And then the next number, 2, we're going to multiply that by 16 to the second power. So we have 2 times 16 squared plus 3 times 16 to the first power, and then plus, now you need to convert E from a hexadecimal system to a decimal system. So based on the chart that we had before, E corresponds to 14. So this is going to be 14 times 16 raised to the 0 power. So now we just got to do some math. 16 squared, that's 16 times 16, so that's 256. 3 times 16. 3 times 10 is 30, 3 times 6 is 18, so 30 plus 18, that's 48. Anything raised to the 0 power is 1, so this is really 14 times 1, which is 14. Now 2 times 256, that's 512. 48 plus 14, that's going to be 62. And then if we add 512 and 62, that's 574. And so this is the answer in the base 10 system. So that's how we can convert a hexadecimal number in the base 16 system to a decimal number in the base 10 system. Let's work on another one. F7D base 16. Let's convert that to a decimal number. So the first letter on the right, we're going to multiply by 16 to the 0 power. The second one is going to be 16 to the first power. And the last one, 16 squared. So F, we need to change that from a hexadecimal value to a decimal value. So using the chart that we wrote before, hopefully you wrote that down so you don't have to keep rewinding the video. F corresponds to 15. So we're going to have 15 times 16 squared, and then 7 times 16 to the first power. And then we need to change D to a decimal value. D corresponds to 13. So this is going to be plus 13 times 16 to the 0 power. Now 16 squared, we know it's 256. And 7 times 16, that's 112. And this is 13 times 1, which is 13. 15 times 256, that's 3,840. And 112 plus 13, that's 125. So if we add 3840 plus 125, that will give us a final answer of 3965 in the base 10 system. So that's it for this example. Now let's try an example with 4 digits instead of 3. If you want to pause the video, feel free to do so if you wish to work on this example problem. So as before, the first one we're going to multiply by 16 to the 0 power. The next one will be 16 to the first, and then 16 to the second, and then for the fourth digit, 16 to the third power. So let's change A into a decimal value. A corresponds to 10. So we're going to have 10 times 16 to the third power. Next, we need to change B. So B corresponds to 11. So this is going to be 11 times 16 squared. And then we have 0 times 16 to the first power, and then 9 times 16 to the 0 power. Now 16 to the third power, that's 16 times 16 times 16. So that's 4,096. 16 squared, we know it's 256. 0 times anything is 0, and 16 to the 0 power is 1, so 9 times 1 is 9. Now 10 times 4,096 is 40,960. You just need to add a 0 to that number. 11 times 256, that's going to be 2,816, and then plus 9. So let's go ahead and add up these three numbers. So this will give you 43,785 as the final answer. Now let's try a 5-digit example. D3E5C base 16. Go ahead and work on that example. So we're going to multiply the first one by 16 to the 0, and then the second one by 16 to the first, and then 16 squared, and then 16 to the third, and for the fifth digit, it's going to be 16 to the fourth. So let's begin by converting D into its decimal value. So D corresponds to 13. Thus, we're going to have 13 times 16 to the fourth power. And then the next number is 3. So it's going to be 3 times 16 to the third. And then we have E. So that's going to be E, not E, we got to change that. E corresponds to 14. So it's 14 times 16 squared. And then it's going to be 5 times 16 to the first power. And then we need to change c. So c corresponds to 12. So it's 12 times 16 to the 0 power. 16 to the 4th power. If you multiply 16 4 times, it's going to be 65,536. And then 16 to the 3rd power, in the last example, we saw that it was 4,096. 16 squared is 256. 5 times 16 is 80. 12 times 1 is 12. Now let's multiply 65,536 by 13. And so that's going to be 851,968. And then it's 3 times 4,096, which is 12,288. And then we have 14 times 256. So that's 3,584. And then 80 plus 12 is 92. So let's add these numbers. So the total sum that you should now have is 867,932. And so this is the final answer for this example. Now let's consider one more example. So let's say if we have a fractional hexadecimal number. So as you can see, we have a decimal point. How can we convert this into a base 10 number? So go ahead and try this problem. Well, we know the first digit to the left of the decimal point is going to be multiplied by 16 to the 0 power. And then the next one is 16 to the first, and then 16 to the 2nd power. But what about the digits to the right of the decimal point? Well, notice the exponents. As you go from left to right, they're decreasing. The next integer less than 0 is -1. So we're going to multiply c by 16 to the -1 and 8 by 16 to the -2. So let's write this out. So we have 3 times 16 squared, and then let's change b to its decimal value. B corresponds to 11, so that's 11 times 16 to the 1st power, and then plus 4 times 16 to the 0 power. Now we need to change c. C corresponds to 12, the next number beyond 11, because c comes after b. And so that's going to be 12 times 16 to the -1, and then 8 times 16 to the -2. Now, 16 squared is 256. So we're multiplying 3 by 256. And then 11 times 16, that's 176. And then we have 4 times 1, which is 4. Now, what do we do here? It's important to understand that 16 to the -1 is basically 1 over 16. So what we're doing is we're dividing. We're going to take 12 and divide it by 16. And now 16 to the -2, that's 1 over 16 squared, which is the same as 1 over 256. And so we're going to divide 8 by 256. So this is going to be plus 8 divided by 256. 3 times 256 is 768. And then if we add 176 plus 4, that's going to be 180. Now 12 divided by 16 as a decimal, that's 0.75. And then 8 divided by 256 as a decimal, that's 0.03125. So let's go ahead and add these numbers. And so you should get 948.78125. And this is in the base 10 system. So that's how you can convert a fractional hexadecimal value into a decimal value. Thanks for watching.
Converting decimal numbers to hexadecimal numbers. Decimal to hexadecimal conversion can be achieved by applying the repeated division, remainder, or logarithms. Simply put, the decimal number is repeatedly divided by radix 6 between this subdivision. The remainders give the hex equivalent in reverse order. Here is how to convert decimal to hex by step. If the given decimal number less than 16, the hex equivalent, some remembering that letters A, B, C, D, E, and F are used for the values 10, 11, 12, 13, and 14, and 15. Convert accordingly. For example, the decimal number 15 will be F in hex. Step 2. If the given decimal number is 16 or greater, divide the number by 16. Step 3. Write down the remainder. Step 4. Divide the part before the decimal point of your quotient by 16 again. Write down the remainder. Step 5. Continue this process dividing by 16 and nothing remainders until the last decimal digit you left is less than 16. Step 6. Write the last decimal digit less than 16 and the quotient will be less than 0 and the remainder will be digit itself. Step 7. The last remainder you will get will be the most significant digit, your x values, while the first remainder from step 3 least significant digit. Therefore, when you were remainders in reverse order, starting to the bottom with the most significant digit and going to the top, you will reach the hex values of given decimal number.
In this video, we're going to talk about how to convert a decimal number to a hexadecimal number. So how can we do this? Well, first, you need to understand that the decimal number is based on a base 10 system. For example, let's say if we have the digit 49. The first digit can be anything from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same is true for the second digit. We have 10 options to choose from. So the decimal system is a base 10 numbering system. Now, what about the hexadecimal system? Notice that it's composed of two words, hexa and decimal. Hexa corresponds to 6. Decimal, as we can see here, corresponds to 10. And so if we add 6 and 10, this will give us 16. So the hexadecimal numbering system is a base 16 system. Now, you need to know the numbers that corresponds to the hexadecimal system from the decimal system. So the number 1 in the decimal system has the same value in the hexadecimal system. So 1 corresponds to 1, 2 corresponds to 2, and 3 corresponds to 3, and so forth. 5 corresponds to 5, 6 corresponds to 6. I'm going to continue the pattern here. And I forgot one number, and that's 0. 0 corresponds to 0. I started with 1, but we should have started with 0. Now, once you get to 10, that's where it changes. 10 doesn't correspond to 10. 10 in the decimal system corresponds to A in the hexadecimal system. 11 in the decimal system corresponds to B. 12 corresponds to C. 13 corresponds to D. And then 14 corresponds to E. 15 corresponds to F. And you stop at 15 because when you include 0 going up to 15, that's 16 numbers. And so the hexadecimal system is based on 16 different numbers and letters. Now, what we're going to do is we're going to talk about how to convert a decimal number to a hexadecimal number using a calculator, because you can easily do it with a calculator very fast. And also, just in case you get a test where it says, do this problem, no calculator. And if you get that, we need to know how to do it without a calculator. So make sure you understand the basics of long division. If you don't, I recommend watching a video I created on long division. It's on YouTube. So if you type in long division, organic chemistry tutor, it should come up. But let's begin. Let's start with 479. So how can we convert 479, which is a base 10 number, that's a decimal number, into a hexadecimal number? How can we do this? The first step is to take 479 and divide it by 16. So we said we're going to use a calculator for this, so let's go ahead and do that. 479 divided by 16 is 29.9375. So here we have an integer of 29, and then we need to find the remainder. To find the remainder, multiply 16 by 0.9375. So 16 times 0.9375, that will give you a remainder of 15. Then you start with this number, 29, and divide that by 16. So let's move on to the next row. So 29 divided by 16, that's equal to 1.8125. So that's one remainder, and to find the remainder, multiply 16 by 0.8125. And so that will give you a remainder 13. And then you need to take the 1, divide that by 16. Now we really don't need to do the division here because 1 doesn't go into 16. 16 doesn't go into 1. So we could say it's 0, remainder 1. But if you did it, let's say if you've taken 1 and you divide it by 16, you're going to get 0.0625. So looking at this number, you'll see that we need to put a 0 here. And then if you multiply 16 by 0.0625, you'll get 1. But you really don't need to do the division. You can see that 16 goes into 1 0 times with a remainder. Now once you get a 0, this is when you stop. So focus on these numbers, 1, 13, and 15. I'm going to rewrite it, but let me get rid of this stuff first. So we had 1, 13, and 15. So the remainders, you want to convert them to hexadecimal numbers. 1 as a decimal is 1 as a hexadecimal. And based on the chart that we wrote earlier, 13 corresponds to D and 15 corresponds to F. Now 1 is the most significant digit and F is the least significant digit. So we need to write it in this order, from the most to the least significant digit. So therefore, 479 in the base 10 system as a decimal is 1DF as a hexadecimal. So we can write a subscript of 16 to indicate that this is a hexadecimal number. And so that's how you can convert a decimal number to a hexadecimal number using a calculator. Now let's try another example. 894. Feel free to pause the video. Use a calculator to convert the decimal number into a hexadecimal number. So let's start with 894 and let's divide it by 16. 894 divided by 16 is 55.875. So that's going to be 55 remainder, and take 8.75 and multiply it by 16. And so that's going to give you a remainder of 14. Now, let's use this number, 55, or you could say this number that we have here, and let's divide that by 16. $55 divided by 16, that's 3.4375. And so we have 3 remainder, and then take 0.4375, multiply that by 16, and that will give you remainder 7. Now, let's take 3. 3 divided by 16, that's going to give us a number less than 1. So we can go straight to the answer. That's going to be 16 goes into 3 0 times with 3 remaining. If you do 3 over 16, you'll get 0.1875. And so here you have a 0, and then 0.1875 is going to be 3. So that's a remainder of 3. If you do 0.1875 times 16, that will give you 3. Now let's convert the remainder values to hexadecimal values. So 3 as a decimal is 3 in the hexadecimal system. 7 is still 7. Now 14 corresponds to a letter. So using a chart, 14 corresponds to E. So we're going to write it from the most significant digit to the least significant digit. Thus 894 is 37E in the hexadecimal system. And so that's it for this example. Now let's try an example without a calculator. Let's use a bigger number, 3284. So convert this decimal number into a hexadecimal number. So if we're going to do this without a calculator, we need to do long division. How many times does 16 go into 32? 16 goes into 32 2 times. 16 times 2 is 32. So we get a remainder of 0, and so we need to bring down to 8. Now how many times does 16 go into 8? 16 goes into 8 0 times. 16 times 0 is 0, and so we still get a difference of 8. So now we need to bring down to 4. How many times does 16 go into 84? 16 goes into 84 5 times. 16 times 5 is 80. And so we get a remainder of 4. So it's going to be 205, remainder 4. So then we write this. 3284 divided by 16 is 205, remainder 4. So now we need to divide 205 by 16. So let's use long division. Let me do it over here. How many times does 16 go into 20? 16 goes into 20 one time. 16 times 1 is 16. 20 minus 16 is 4. And then we need to bring down to 5. Now how many times does 16 go into 45? 16 times 2 is 32, but 16 times 3 is 48, which is too high. So it goes into it 2 times. And then 45 minus 32 is 13. So 205 divided by 16 is 12, remainder 13. Now for the last one, we need to divide 12 by 16. So 16 doesn't go into 12. It goes into 12 0 times with a remainder of 12. So now let's focus on these numbers. Let's convert them to hexadecimal values. So 12 in the decimal system corresponds to C in the hexadecimal system, 13 corresponds to D, and 4 corresponds to 4. So we're going to read it this way, starting with C. So it's going to be C, D, 4, base 16. And so that's how you can convert a decimal number to a hexadecimal number using a calculator. Actually, I meant to say without using a calculator. So let's do another example like that. 7,956. So convert this base 10 number into a hexadecimal number. So let's begin by taking 7956 and let's divide it by 16. So let's use long division. Now it's good to understand your 16 times tables. If not, keep adding 16. 16 plus 16 is 32. 32 plus 16 is 48. 48 plus 16 is 64. 64 plus 16 is 80. And then 96. And then you could add some more if you need to. So how many times does 16 go into 79? The highest number just under 79 is 64. So 16 goes into 79 4 times. 16 times 4 is 64. Now 79 minus 64 is 15. And so we need to bring down to 5. In this case, we need some more numbers. 96 plus 16 is 112. And 112 plus 16 is 128. 128 plus 16 is 144. And then the next one is 160. When making a list like this, you never need to go past 10. Now, 16 goes into 155 9 times. 16 times 9 is 144. And 155 minus 144 is 11. Now, let's bring down to 6. 16 goes into 116 7 times. 16 times 7 is 112, with a remainder of 4. So we could say that 7,956 divided by 16 is 497, remainder 4. Now, you may want to write this information down, just in case I need to erase it to make more room. So now let's divide 497 by 16. So how many times does 16 go into 49? 16 goes into 49 3 times. 16 times 3 is 48. 49 minus 48 is 1. And then let's bring down the 7. 16 goes into 17 one time, with a remainder of 1. So now I need to erase this. So 497 divided by 16 is equal to 31, remainder 1. So now let's divide 31 by 16. So this we can do in our heads. 16 goes into 31 one time. And the remainder is the difference between 31 and 16, which will be 15. So now let's convert these into hexadecimal values. So 15 corresponds to F. And then, actually no, we're not finished yet. This needs to be a 0. So now we need to divide 1 by 16. 1 divided by 16 is 0, with a remainder of 1. So now we're finished. So don't forget that, because I almost did. And you need to get a 0 here before you could finish. So a remainder of 1. 1 corresponds to 1. 15 corresponds to F. 1 corresponds to 1. And 4 corresponds to 4. So writing it from the most significant digit to the least significant digit, it's going to be 1 F 1 4 base 16. And so this is the answer. Now let's do one more example, but this time we're going to do it both ways. And let's use a bigger number, 14,259. So let's convert this base 10 number into a base 16 number. Go ahead and try it. So first let's use a calculator. 14,259 divided by 16. And so that's going to be 891.1875, which I'm going to write that number here, just to conserve space. So it's 891, remainder, and then take the decimal number multiplied by 16. So 0.1875 times 16, that will give us a remainder of 3. Now, let's take 891 and let's divide that by 16. And so that's going to be 55.6875. So that's 55 remainder, and then take 0.6875, multiply that by 16. So that will give us remainder 11. And then it's going to be 55 divided by 16, which is 3.4375. So we're going to get 3, and then 0.4375 times 16 is 7. Next, 3 divided by 16. 16 doesn't go into 3. So 16 goes into 3 0 times, with a remainder of 3. And that's where we stop. Now let's get rid of this. And let's convert the remainder values into hexadecimal values. So 3 corresponds to 3, 7 corresponds to 7, 11 corresponds to B, and 3 corresponds to 3. So writing it from bottom to top, it's going to be 3, 7, B, 3, base 16. And so that's how you can do it using a calculator. Now let's do it without using the calculator. So we need to take 14,259 and divide it by 16. So let's do long division. Now, if you wrote that list that we had earlier, you'll know how many times 16 goes into 142. 16 doesn't go into 14, so we have to use 142. Now I'm going to rewrite the list. We only need it up to 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 16 goes into 142 8 times. 128 is the highest number just under 142. So 16 times 8 is 128. And 142 minus 128, that's 14. Now, 16 goes into 145 9 times. 16 times 9 is 144. And so we have a difference of 1. 16 goes into 19 one time. And so we get a remainder of 3. So this becomes 8, 9, 1, remainder 3. So now let's take 891 and let's divide that by 16. 16 goes into 89 5 times. 16 times 5 is 80. The difference is 9. 16 goes into 91 5 times as well. And so here the difference is 11. 16 doesn't go into 11, so that's the remainder. This gives us 55, the remainder 11. Now let's divide 55 by 16. 16 goes into 55 3 times. 16 times 3 is 48, and the remainder is 7. So we have 55 divided by 16, which is 3, remainder 7. And then we need to divide 3 by 16, which 16 goes into 3 0 times with 3 remaining. Now let's convert the remainder values to hexadecimal. So 3 corresponds to 3, 7 corresponds to 7, 11 corresponds to B, and then B corresponds to 3. So writing it in this order, we can see that it's going to give us this again. 3, 7, B, 3. And so that's how you can convert a decimal number to a hexadecimal number using both techniques.
Converting hexadecimal number to binary numbers. Converting from hex to binary is straightforward since hexadecimal numbers are simplified version of binary string. You just need to remember that each hex values produce 4 binary digits. Step 1. Write down the number. If there are any changes, the hex values represented by the letters of their decimal equivalents. Step 2. Each hex digit represents 4 binary digits. Therefore, it is equal to a power or rightmost digit equals to 2:1. The next one is equals 2:2, and the next one is 2 is to 4, and then leftmost 1 equals to 3 and 2 is to 3. Write this number 8, 4, 2, and 8 and 1 below the hex values. Step 3. Determine which power of 8, 4, 2, and 1 sum up the value of hex digits. From example, if one of your hex values is 10, this means 8 and 2. The sum of 10, 4, and 1 are not used. If your hex number is 2 and only 2 is used, 8 and 4 and 1 are not. Step 4. Write down below 8, 4, 2, and 1 that use. Write down 0 below those are not used. Step 5. Read ones and zeros from left to right to get binary equivalent of given hex number.
In this video, we're going to talk about how to convert a binary number into a hexadecimal number. So let's start with this example. Let's say we have the binary number 10110111. How can we convert this into a hexadecimal number? The first thing you want to do is separate the binary numbers in groups of 4. So this is the first group of 4, and this is the second group of 4. Now convert the binary numbers into a decimal value. To do so, we need to multiply the 1 by 2 to the 0, and then the second one by 2 to the first power, and then by 2 squared and 2 to the third power. 2 to the third power is 8, 2 squared is 4, 2 to the first is 2, and anything raised to the 0 power is 1. So we have 0 times 8, so that's 0. And then we have 1 times 4, and then 1 times 2, and 1 times 1. So basically, we just need to add up these numbers because they carry a 1 with them. So the binary number 0111 correlates to 7 because 4 plus 2 plus 1 is 7. Now for this one, this is 8, 4, 2, 1. So we're going to add up 8, 2, and 1 because they have a 1 value associated with them. So 8 plus 2 plus 1, that's going to give us 11. Now we need to convert these numbers into the hexadecimal values. 10 corresponds to A, and 11 corresponds to B. So we're going to replace 11 with B. And so we have B7, base 16. So the binary number 10110111 correlates to this in the hexadecimal system. And so that's how you can convert a binary number into a hexadecimal number. Now for the next example, let's say it's 1011101010. Go ahead and convert this binary number into a hexadecimal number. So like before, let's break it up into groups of 4. Now, notice that we don't have 4 numbers here, so we can add 2 zeros. So the first group will be 0010, and then the second group will be 1110, and the last one is 1010. So let's start with the first group. So we have the numbers 8, 4, 2, and 1. So we only have a value of 2 here. For the zeros, just ignore them. So this number, 0010, corresponds to a value of 2. For the second group of 4, we need to add 8 plus 4 plus 2. 8 plus 2 is 10, 10 plus 4 is 14. And for the last one, the significant values are 8 and 2, which will give us 10. Now recall that 10 corresponds to A, 11 corresponds to B, 12 corresponds to C, 13 corresponds to D, which means 14 corresponds to E. We could replace 10 with A. So the answer is going to be 2EA. So it's 2EA in the hexadecimal system. And so that's it. That's how we can convert this binary number into a hexadecimal number. Now let's try another example. 1 1 1 1 0 1 1 1 1 1 1 0 0. Try that one. So let's separate it into groups of 4. So the first group, we're going to add 3 zeros. So it's going to be 0 0 0 1, and then the group in green is 1 1 1 0, and then in blue 1 1 1 1, and in red 1 1 0 0. So for this one, only this number is significant. So we have a value of 1. For the second one, the numbers 8, 4, and 2 are important. So 8 plus 4 plus 2, that's 14. And for the last one, all of them are important. So they add up to 8 plus 4 plus 2 plus 1, that's 15. And for the final one, it's just 8 plus 4, which is 12. So we know 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. And so the answer is 1 E F C in the base 16 system. So this is our answer as a hexadecimal. Now, to make sure that we have the right answer, let's convert the binary number and the hexadecimal number into a decimal value, and let's make sure that it's the same. So let's start with the binary number. So this is 2 to the 0, 2 to the first, 2 squared, 2 to the third, fourth, fifth, sixth, and so forth. So we have a 1 associated with 2 to the 12. So 1 times 2 to the 12, that's going to be 4,096. And then we have 2 to the 11th, which is 2,048. And then 2 to the 10th, which is 1,024. And 2 to the 9th, which is 512. And then 2 to the 7th, that's 128. 2 to the 6th is 64. And then 2 to the 5th, which is 32. And then we have a 16, 8, and a 4, which is the last one, 2 squared. So if we add up these numbers, 4,096 plus 2,048 plus 1024 plus 512 plus 128 and all the way to 4, this will give us 7,932. So now let's convert the hexadecimal number into a decimal number. Let's see if we get the same thing. So we have 1 E F C. So we know E corresponds to 15. And E corresponds to 14, F corresponds to 15, and C corresponds to 12. We need to multiply C by 16 to the 0 power, F by 16 to the first, E by 16 squared, and 1 by 16 cubed. So it's 1 times 16 cubed, and we said E corresponds to 14, so it's going to be plus 14 times 16 squared, and F is 15, and then C is 12. 16 to the third power, that's 4,096. 16 squared is 256 times 14, that's 3,584. 15 times 16 is 240. And 16 to the 0 power is 1 times 12 will give us that. So now let's add up 4,096, 3,584, 240, and 12. And so this will give us the same answer, 7,932. So that's how you can check your work, which means that this indeed is the right answer. And so that's it for this video. Now you know how to convert a binary number into a hexadecimal number. At the same time, you also know how to convert a binary number into a decimal number and also a hexadecimal number into a decimal number. So thanks for watching.
Converting binary numbers to hexadecimal numbers. Converting from binary to hex is easy since hexadecimal number are simplified version of binary strings. You just need to remember that each hexa digit represents binary digits. It follows that 4 binary digits will be equal to 1 hex digit. The method is easier than it sounds, but it's always useful to use a binary in the hex conversion chart to save time. Step 1. Write down the binary numbers and group the digit 0s and 1. In set of 4, start doing from the right. Leftmost group doesn't have enough digits to make up a set of 4 and extra zeros to make a group. Step 2. Write 8, 4, 2, and 1 below each group. These are ways of the position of our placeholders. Number 2:3, 2:2, 2:1, and 2:0. Step 3. Every group of 4 binary will give you 1 digit hexadecimal. Multiply 8, 4, 2, and 1 by the digit above. Step 4. Add the product within each set of 4. Write the sums below the group they belong to. Step 5. The digits you get from the sum in each group will give the hexadecimal number from left to right.
In this video, we're going to focus on operations associated with binary numbers. How do you add two binary numbers together? How do you subtract them? How do you multiply them? How do you divide two binary numbers? So let's start with the basics. What's 0 plus 0? 0 plus 0 is 0. Now what about 1 plus 0? How can we add those two binary numbers? 1 plus 0 is 1. Now there's some other basic rules to go over. What about 1 plus 1? In this case, we need to carry over. 1 plus 1 is going to be 0, but you need to carry over a 1. And so you get 1, 0. So basically, 1, 0 has the decimal equivalent of 2. Now what if you have 3 1s? How can you add this? In this case, it's going to be 1, and you carry over a 1. Let's write that here. And so you get 1, 1. So if you have 3 1s in a single column, it's going to produce an output of 1, 1. Now let's work on some example problems. Go ahead and add these two binary numbers. 1010 plus 1001. Now the first thing you should do is you should line up these numbers. And then add up the numbers column by column. So here we have 0 plus 1, which is 1. In the next column we have 1 plus 0, which is also 1. And then for the third column, 0 plus 1, that's 0 plus 0 rather, which is 0. And then for the last one, it's 1 plus 1, which is going to be, based on the last two examples, 0, but you need to carry over a 1, so you get 1, 0. Now, to check the work, let's convert each binary number into a decimal number. So let's separate this into columns. So this is 1, 2, 4, 8, and 16. So 1010 is going to have the decimal equivalent of, this is going to be 8 plus 2 because it's in this column. 8 plus 2 is 10. So that's the decimal equivalent of 1010. Here we have an 8 and a 1. So 8 plus 1 is 9. 10 plus 9 is 19. So here we have a 16 plus a 2 plus a 1. So that adds up to 19. And so we can see that we have the right answer. So this is our answer right here. So that's how you can add two binary numbers. Now let's go ahead and try another example. Go ahead and add these two binary numbers. Feel free to pause the video if you want to try this example. So let's start with the column on the right side. 0 plus 1 is going to be 1. And then in the next column we have 1 plus 0, which is 1. And then it's 1 plus 1, which is going to be a 0, but we need to carry over a 1. Now for the fourth column, it's 1 plus 0 plus 0, which will equal 1. And then we have 0 plus 1, which is 1. And then next is 1 plus 1, which is 0, but carry over a 1 to the next column, which will give us 1. So now let's confirm our answer. But let's separate everything into columns, just like we did before. So this is going to be 1, 2, 4, 8, 16, 32, and 64. So let's get the decimal equivalent of the first number. So we have a 32 plus a 4 plus a 2. 32 plus 4 is 36 plus 2, that's 38. And then for the next one, we have a 32 plus 16, which is 48. 48 plus 4 is 52, plus 1, that's going to be 53. Now 8 plus 3 is 11, carry over the 1. 5 plus 3 is 8, plus 1, that's 9. So this should equal 91. So we have a 64 plus 16, so that's 80, plus 8, that's 88, plus 2 is 90, plus 1, 91. So we can see that we do indeed get the right answer. And so now you know how to add binary numbers. As you can see, it's not very difficult as long as you follow the process. So make sure you remember these two things. When adding 1 plus 1, you're going to get a 0, but you need to carry over a 1 to the next column. And so the end result is that you get 1 0. And if you're adding 3 1s together, it's going to be 1, but you carry over another 1, and so instead of getting 1 0, you get 1 1. And if you remember these two things, you can easily add two binary numbers together. For the sake of practice, let's work on another example. So go ahead and add these numbers. So feel free to take a minute, pause the video, and work on this example problem. So let's start from the first column on the right side and work our way towards the left. 1 plus 1, we know that it's going to give us 0, but we need to carry over a 1 to the next column. 1 plus 0 is going to be 1. And then in the third column, we have 1 plus 1, which is 0, but we got to carry over a 1. Now for the fourth column, we have 3 1s. Do you remember what we need to do if we encounter this situation? If you have 3 1s in a single column, it's going to give you a 1 for that column, but you need to carry over another 1 to the next column. And so 1 plus 0 plus 1, we could ignore the 0, and so it's the same as 1 plus 1, which will give us a 0 for that column, but we got to carry over a 1. And for the last column, we have 3 1s again, so it's going to produce a 1 for that column, but we need to carry over another 1 for the next column. So 1 plus nothing is going to give us 1. And so this here is our final answer. But as always, let's confirm it. So let's begin by drawing lines to separate the columns from each other. And then let's write the powers of 2. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth is 32, and 2 to the sixth is 64. So let's convert the first binary number into its decimal equivalent. So we have a 32 plus 8. 32 plus 8 is 40, plus 4, that's 44, plus 1, so that's a total of 45. Next, we have a 1 for the 32 column, so that's 32, plus a 1 for the 16 column, so 32 plus 16, that's 48, plus 8, that's 56, plus 4, that's 60, plus 1, and so that's going to be 61. Now 1 plus 5 is 6, 4 plus 6 is 10, so we get 106. Now we have a 64 plus a 32, so that's 96. 96 plus 8 is 104. 104 plus 2 is 106. And so our answer is indeed correct. So this is the final answer right here. 1101010. Now let's move on to our next topic, that is how to subtract binary numbers. So let's start with this. what is 1 minus 0? 1 minus 0 is simply 1. Now what about 1 minus 1? 1 minus 1, they cancel, and that's 0. Now what if you have 1, 0, but you wish to subtract it by 1? What will you do? Now 1, 0 as a binary number is equivalent to 2 in the decimal system. And 1 is just 1 in the decimal system. So 2 minus 1 should give us an answer of 1. Now, we can't do 0 minus 1 because that's going to give us a negative number. So we need to borrow. So we're going to borrow this 1. That's going to turn into a 0. And then this 0 becomes a 2. 2 minus 1 is 1. And 0 minus nothing is 0. So 0, 1 corresponds to 1. Now, what if we have this situation? Let's say it's 1, 0, 0 minus 1, 0. Now, this column is for the 1s, 2, and 4. So 1, 0, 0 is basically 4. And 1, 0 is 2. 4 minus 2 is 2. So this is the answer we should get. Starting with the first column, 0 minus 0 is 0. Now, 0 minus 1, we can't do that, so we need to borrow a 1. So that's going to disappear, that's going to change to 0, and this becomes a 2. 2 minus 1 is 1. And you could bring the 0 down if you want to. 0, 1, 0 has the decimal equivalent of 2, so this answer is correct. Now, let's try this one. 1, 0, 0 minus 1. Go ahead and subtract those two binary numbers. So we can't do the first column. 0 minus 1 will give us a negative number, so we need to borrow a 1. Now we can't borrow anything from this column because it's a 0. So we need to borrow a 1 from a column that has a 1. So this becomes a 0, and this column becomes a 2. So anytime you cross out a 0, replace it with a 2. It's going to work if you do it that way. Now we still need something in this column. So let's borrow a 1 from the 2. So this becomes a 1, and this becomes a 2. Now we can subtract. So 2 minus 1 will give you 1. And then you can bring down the 1 here because there's nothing to subtract it. 1 minus 0 will be 1. And you can bring down the 0 as well. Now let's check the work. So 1, 0, 0 as a binary number has a decimal equivalent of 4. And here we just have 1. So 4 minus 1 is 3. Now looking at this number, this is 1, 2, 4. So we have a 1 with the 2 and 1. 2 plus 1 is 3. And so that tells us that we do have the right answer.